Hello students, so in this video we are going to discuss about the topics which are left in this chapter of structure of matter. So this is the part 3. So till now we have covered what is element, what is mixture, what is compound, and what is atomicity, what is symbol, what is chemical formula in little bit. So here we are going to start with the topic of valency. So what is valency? Remember, valency is the combining capacity of any element. So any element, so specifically we are talking about atom of any element. So because atoms are the unit of element which are going to do this chemical reaction or chemical combination. So when we talk about the valency, it is about the atom of that particular element. Okay, now the thing is, this combining capacity is the chemical property of any element. So how this element is going to combine with the atom of other element, that may be same element, that may be different element, to form molecule. Now, as for it is widely accepted or universally accepted that hydrogen is having the combining capacity or valency of 1. That means hydrogen can accommodate one more element with it to form a stable molecule. Similarly, you can see oxygen is having 2 valency, or it is having the capacity to accommodate 2 atom of any element. Generally, the atom which is going to combine with oxygen is of same element, remember, like this. So for this particular thing, if you can take the example of H2O, that is water. So H2O, so oxygen is having the combining capacity of 2. That means it can accommodate 2 atom of any different element. So in case of H2O, O is accommodating 2 hydrogen atom, H2. So that is why. So that is basically the combining capacity. Now moving ahead, if we talk about hydrogen, so hydrogen can accommodate 1 oxygen atom in this particular H2O. Okay, now in general term, the valency of other elements. So every element is having valency. So other element in general term is so what is valency? So it is the number of hydrogen atom which can combine with or displaced by one atom of that element. So if we talk about elements like carbon or any other element like nitrogen, so valency of these nitrogen or carbon can be decided by simple rule that how many hydrogen atom they can accommodate to form a single stable molecule. For example, in case of ammonia, we have already seen the example of ammonia in the previous video. So NH3 was the compound, that is ammonia, NH3. So nitrogen is accommodating 3 hydrogens. So indirectly we can say that the combining capacity of nitrogen is 3. Whereas if we talk about the compound like CH4, that is methane, so carbon is accommodating 4 hydrogen. So the valency of carbon will automatically become 4, because as per this definition it is accommodating 4 number of hydrogen atom in CH4, that is methane. Okay, similarly the valency of some element like helium, like neon, like krypton is taken as 0. I have already told you that these helium, neon and krypton are stable element. They are non-reactive. So their valency is 0. So they are not going to combine with any other element or atom of any other element. So they are stable, and that is why their valency, their combining capacity is 0, because they are already stable. So remember one thing, at the last I would like to say one thing: the atom of an element which is reactive is going to react with the other atom of the element so that it can form stable molecule or stable compound. If it is already stable, like helium, like neon, like krypton, so these elements are not going to react with other element, because stability is their priority. They want to get stable, that is why they are forming bonds with other elements. Now moving ahead with this particular example of valency of some element. So you can see hydrogen is having the valency of 1. Remember, this is very crucial part. And sodium is also having 1. Sodium, like sodium hydroxide, sodium chloride. So the valency of sodium is always 1. Similarly, potassium is also having 1 valency. Oxygen, we have already studied, it is having 2 valency, or combining capacity is 2. And calcium is again 2, aluminium 3, carbon. So remember, carbon, I have already given you the example of CH4. So where it is 4. So combining capacity is 4. Iron is showing 2 type of valency. Either it is 2 or it is 3. So that kind of valency is basically known as variable valency. So iron, when it is in the form of ferric oxide, so it is going to show 3 valency. When it is in the form of ferrous oxide, then it will be showing its 2 valency. So that depends upon what type of compounds we are talking about in the case of iron. So this is known as basically variable valency in the case of iron. Now how we can write the formula. So using the valency property, so we can derive the formula of any compound. So let us do it step by step. So here, first of all, you have to remember this step. First of all, what we have to do is we have to write the symbol of the elements. So those are going to form the compound. So these two elements, let's say we are having two elements to form one compound. So we have to write it side by side, and then we have to write their valency onto the top side, and then interchanging them at their base. So just look at this particular slide, you will get the example of writing sodium oxide. So how we can write this formula? So this is sodium and this is oxygen. So here we have to write side by side like this, sodium and oxygen. No need to put in circle. Remember, Na and O is sufficient to write. So this is just to illustrate you. So now next step is to write the valency onto the top right side. So like this we can write their valency here and here. So sodium, we have already seen in the table that it is having 1 valency, and oxygen, the valency is 2. Now we have to interchange their number to diagonally to their bases like this. So here you can see the valency of, that is 1 of sodium, will go to the this side, and 2 number will go to the opposite side. So in this way the component or the compound which is going to form will be like this. So Na2O is the overall formula for sodium oxide. Remember, so Na2O is the formula for sodium oxide. Similarly, you can write the formula of other compounds also. Like if you want to write the formula of NaCl, so it is again sodium chloride, it is NaCl. Like sodium hydroxide, it is NaOH. So likewise you can write. Okay, now we are talking about the next segment after the valency. This is again very important topic, that is chemical equations. So what is chemical equation? Remember, chemical reactions are the process in which a new substance with new properties are going to form. So that is basically known as chemical reaction, and we have seen many chemical reaction in the chapter acid, base and salt also. So like in that I have shown you the video in which we are putting baking soda into the vinegar, and CO2 gas is producing out. So this way a chemical reaction is going on. Similarly, we can have the formation of salt also, so in the neutralization reaction. So these reaction, if we are going to write this reaction with the help of symbols which we have already studied and formulas, so that will become chemical equation. So what is chemical equation? It is the method of representing a chemical reaction with the help of symbols and formula of substance involved in it is known as chemical equation. So here we can have, this is the example of chemical equation. Here you can see iron, so this is the reactant part. So left side of the arrow, so this is the arrow, so left side of the arrow is showing the reactant part, and right side of the arrow is showing the product part. So these reactants are combining with each other to form the product. So this arrow mark is going toward the product side. So this is showing in which direction reaction is proceeding. So this is the reactant and this is the product. So this whole writing is basically chemical equation. Now the thing is, As I have already told you, left side are reactants, right side are products. So remember, when we talk about chemical equation, so the type of element involved in this reactant side will be equal to the type of elements onto the right side, that is the product side. And remember also their number, how many number of Fe, that is iron, and S, that is sulfur, is present. So that will also going to be remain equal onto the left hand side and onto the right hand side. So this is the rule of chemical equation, that both reactant type of element and their number of atom present in this reactant will remain same onto the left hand side and onto the right hand side. Otherwise the equation will not be called a balanced equation, it will be unbalanced equation. So every time we have to write the chemical equation, and yes, we have to balance it also. So in this next slide we are going to study about how we are going to balance the chemical equation. So let us say we are having the example of nitrogen reacts with hydrogen to give ammonia. So this is the chemical reaction and we have to write the equation which is balanced. So now the first step is the nitrogen is written as in molecular form. So N2, that means it is a molecule, diatomic molecule, as we have already studied in the atomicity. So N2 is nitrogen. So nitrogen cannot be written as single N. It will always be written as N2. Similarly, hydrogen. So hydrogen is again diatomic molecule. So here hydrogen will always be written as H2, not as H. Remember. So this you have to keep in mind. Similarly, chlorine is also there, Cl2. You have to write. So here the number of N is 2 and here a hydrogen atom is 2. So when they are going to combine together in the presence of heat and other condition, so they are going to form this compound, that is NH3. So here you can see N is equal to 1. So there is the number of N atom present in this compound ammonia is 1 and H is present, that is in 3 numbers. So if you are going to compare it, so you can see nitrogen is 2 whereas here it is 1. So onto the reactant side hydrogen is 2 whereas it is 3 over product side. So this equation is not balanced. So this equation is known as unbalanced equation because the number of atom of element is not same onto the LHS and RHS, that is the left hand side, this side and this side. Now we have to balance it. So how we are going to balance it? So the simple method we use is hit and trial method. So now we know that here the nitrogen is less, here it is 2 and here it is 1. So what we do, we will add a number that is 2 as coefficient in front of NH3. So here we are going to write 2. So this 2 which we have written is going to multiply with the number of atom of nitrogen and number of atom of hydrogen. Like number of nitrogen atom is 1 and hydrogen is 3. So 2 is going to multiply with this 1 and 3. So N will become 2, 1 is 2 like this. So N will become 2 and 2, 3 is 6. So hydrogen will become 6. So ultimately by adding 2 over here onto the right side, the nitrogen and hydrogen will change into N will become 2 and hydrogen atom will become 6. On to the left side, but the thing is it is only N2 and H2. So still it is unbalanced. So what we have to do? So we have to go with next step. So right now here you can see if we are going to compare. So you can see here that nitrogen is 2 but here nitrogen is also 2. So nitrogen is balanced but only the hydrogen problem is there. So what we have to do is next step we are going to add 3 number. We are going to add 3 in front of hydrogen. This is the third step. So by adding 3, so simply writing 3, so this 3 is going to multiply with this 2. So obviously hydrogen will become, so as you can see, so hydrogen will become 6 because 3 into 2 is equal to 6 and nitrogen is already 2. So here also nitrogen is 2, hydrogen is becoming 6 and right side also the same scenario, nitrogen is 2 and hydrogen is 6. So now we can see both sides are equal in number of nitrogen or in number of hydrogen if we are talking about. So both are equal. So this is how we can balance the chemical equation. So the side which is having a deficiency of atom, so we can add the specific number onto the coefficient part, like here we have added 2, similarly here we added 3, like this. So this we can do. So this is hit and trial method. So ultimately at last we will get the balanced number of atom of both the element onto the left side and onto the right side. So this is basically the example of balancing of chemical equation. So this is all about this particular chapter. So we have covered everything. So just go through this video, because this particular content is going to help you in the next chapter which we are going to start, that is physical and chemical changes. And no doubt this concept is already there in the acid, base and salt. So be prepared for the next chapter and just go through this all three videos continuously. Okay, thank you.